Hello learners, welcome to Unacademy SN YouTube channel. This is Umamaheshwara Rao. Today's topic is application of standard limits. Follow me on my Telegram channel, Umasar Mathematics. Feel free to ask your doubts. I will be available on this WhatsApp number 9392669703. Follow my Facebook page, Umamaheshwar Mathematics, for daily practice problems which will boost your preparation for ESE and GATE, and also improve your problem solving skills to tackle GATE examination. I have scheduled a few YouTube classes this month regarding the basics for my upcoming course, detailed course on Engineering Mathematics Part 2. This course includes calculus, vector calculus, differential equations, partial differential equations, transform theory, Fourier series. The course commences from 15th July, 3 p.m. to 5 p.m. In this course, I will be covering each concept from its basics. This course will be helpful for all the engineering branches. Unacademy now launches 2-year batch courses for GATE and ESE aspirants, putting together excellent educators in each field. The entire syllabus for ESE and GATE will be covered in this program. So let's begin. Limit x tends to infinite, e power 1 by 5x minus 1, 5x plus x by 5 into sine 1 by x. We have to evaluate this limit when x tends to infinite. Limit x tends to infinite, e power 1 by 5x minus 1 multiplied with 5x plus x by 5 sine 1 by x. When x is tending to infinite, 1 by x is tending to 0. Limit 1 by x tends to 0, e power 1 by 5x minus 1 into 5x plus e power 1 by 5x minus 1 x by 5 sine 1 by x. Right? Now, limit 1 by x tends to 0, e power 1 by 5x minus 1 by 1 by 5x plus limit 1 by x tends to 0, e power 1 by 5x minus 1 x by 5. I am going to write 1 by 5 into sine 1 by x by 1 by x. This x is written as 1 by 1 by x. Understood? Now, Here limit 1 by x tends to 0, e power 1 by 5x minus 1 by 5x can be written as 1 plus 1 by x tends to 0, e power 1 by 5x minus 1 minus 1, 0, 1 by 5, sin t by t tends to 0, 1. Finally, 0 multiplied with 1 by 5 into 1 will become 0. So here you have 1. So final answer is 1. Therefore, correct answer is second option. Understood? Next problem. Limit x tends to 0, e power x cos x into cos x power 1 by sin square x. Right? Limit x tends to 0, e power x multiplied with cos x whole power 1 by sin square x. I am going to write limit x tends to 0, e power x. Yeah, cos x can be written as 1 minus sin square x whole power 1 by 2 power 1 by sin square x. This can be written as limit x tends to 0, e power x 1 minus sin square x 1 minus sin square x power 1 by sin square x whole power 1 by 2. Right? We have one formula. Limit x tends to 0, 1 plus x whole power 1 by x is e. By applying this formula here, you will get limit x tends to 0, e power x, limit x tends to 0, 1 minus sin square x whole power 1 by sin square x whole power 1 by 2. This limit is 1. This limit 1 minus t whole power 1 by t. Your formula is 1 plus t whole power 1 by t. T tends to 0 gives you e. So here this will give you e power minus 1 whole power this 1 by 2. Right? Therefore, e power minus 1 by 2. Final answer is e power minus 1 by 2. Correct option is second option. Understood? Try this problem. Limit x tends to 0 sin pi cos square x by x square. Based on standard limits only. Limit x tends to 0 sin pi cos square x by x square. Try this one. Now, limit x tends to 0 sin pi cos square x can be written as 1 minus sin square x by x square. Limit x tends to 0 sin of pi minus pi sin square x by x square. Sin pi minus pi sin square x, sin 180 minus pi sin square x, sin 180 minus theta, sin theta. That's why you can write limit x tends to 0 sin 180 minus pi sin square x is sin pi sin square x by x square. This can be written as limit x tends to 0 sin pi sin square x by pi sin square x. I have divided with pi sin square x. That's why I am going to multiply with pi sin square x by this x square. I am going to write here. This is in the form of limit x tends to 0 sin pi sin square x by pi sin square x pi by 1 sin x whole square by right sin x whole square by x square, sin x by x form. It is in the form of sin t by t tends to 0. This is 1. This is pi. Sin pi sin square x by pi sin square x is 1. So finally 1 multiplied with pi multiplied with 1 pi. So answer is pi. Understood? Now limit n tends to infinite n tends to infinite, 1 minus 2 plus 3 minus 4 plus 5 minus 6 and so on minus 2n by square root of n square plus 1 plus square root of n square minus 1. Try this one. Limit n tends to infinite, 1 minus 2 plus 3 minus 4 plus 5 minus 6 till minus 2n. Muhammad Amiruddin, if you follow Unacademy Plus videos, that will be sufficient. Practice daily practice problems. Now, here limit n tends to infinite, 1 minus 2, 3 minus 4, 5 minus 6. We continue like that. 1 minus 2 is minus 1 plus 3 minus 4 minus 1 plus 5 minus 6 minus 1. Like that, here till minus 2n. So here minus 1. How many times? N times by square root of n square plus 1 plus square root of n square minus 1. Limit n tends to infinite, minus 1 minus 1 minus 1 minus 1 n times is nothing but minus n by square root of n square plus 1 plus square root of n square minus 1. Here n is tending to infinite. That's why take n common in the denominator. If you take n square common within the square root, outside it will become n. Limit n tends to infinite, minus n by n of square root of 1 by n square plus square root of 1 minus 1 by n I have taken n common. Now when n tends to infinite, 1 by n square tends to 0. That's why limit n tends to infinite minus 1 by square root of 1 plus 1 by n square, square root of 1 minus 1 by n square gives you minus 1 by 1 plus 1, that is minus 1 by 2. So here the answer is minus 1 by 2. Rekha, uh, every day till 15th the YouTube classes scheduled. You can attend. Basic concepts of limits you will get. Next column, limit n tends to infinite 2 power n plus 1 plus 3 power n plus 1 by 2 power n plus 3 power n. Try this one. Limit n tends to infinite 2 power n plus 1 plus 3 power n plus 1 by 2 power n plus 3 power n. Limit n tends to infinite 2 power n plus 1 can be written as 2 power n into 2. 3 power n plus 1 can be written as 3 power n into 3 by 2 power n plus 3 power n. Limit n tends to infinite. Here, take 3 power n common in the numerator as well as in denominator. If you take 3 power n common, you will get 2 by 3 whole power n multiplied with 2 plus 3 by taking 3 power n common, 2 by 3 whole power n plus 1. Now you can cancel 3 power n, 3 power n. When n tends to infinite, 2 by 3 whole power n tends to 0. When n tends to infinite, 2 by 3 whole power n tends to 0, because the value of 2 by 3 is less than 1. The value of 2 by 3 is less than 1. That's why whenever n tends to infinite, 2 by 3 whole power n tends to 0. That's why I have taken 3 power n common. Now, limit n tends to infinite, 2 by 3 whole power n into 2 plus 3 by 2 by 3 whole power n plus 1. When n is tending to infinite, 2 by 3 whole power n tends to 0. This 2 by 3 whole power n tends to 0. That's why you will get 3 by 1. That is nothing but 3. Therefore, answer is 3, which is given in first option. Next problem. Try this one. If currently now it's fine, right? Yeah, try this problem. Limit x tends to 0, 1 plus cx by 1 minus cx power 1 by x is 4. Then limit x tends to 0, 1 plus 2cx by 1 minus 2cx power 1 by x is 1 minus 2cx power 1 by x is. Formula is limit x tends to 0, 1 plus x whole power 1 by x is e. Limit x tends to 0, 1 minus x whole power 1 by x is e power minus 1. This is the suitable formula we have to apply in this problem. Given that limit x tends to 0, 1 plus cx whole power 1 by x by 1 minus cx whole power 1 by x is 4. That is given in the data. Limit x tends to 0, 1 plus cx whole power 1 by x by 1 minus cx whole power 1 by x is 4. It means limit x tends to 0, 1 plus cx whole power 1 by x by limit x tends to 0, 1 minus cx whole power 1 by x equal to 4. Numerator is e power c. Denominator is e power minus c equal to 4. That is e power 2c equal to 4. That is the conclusion we got from the given statement. Now we have to find out limit x tends to 0, 1 plus 2cx by 1 minus 2cx power 1 by x. Therefore, you can write limit x tends to 0, 1 plus 2cx whole power 1 by x by 1 minus 2cx whole power 1 by x. It is nothing but e power 2c by e power minus 2c. It is nothing but e power 2c by 1 by e power 2c. That is e power 2c whole square, e power 4c. From the given statement, you got e power 2c value 4. Now, since e power 2c is 4, the square on both sides, e power 4c will be 16. Therefore, correct answer is 16. Since e power 2c is 4, therefore e power 4c is 16. Next column. The value of the limit x tends to 0, 5 power x minus 3 power x by 3 power x minus 2 power x. Limit x tends to 0, 5 power x minus 3 power x by 3 power x minus 2 power x. Try this one. Tell me the answer. Take 3 power x common. Very good, Chanchal. Limit x tends to 0. If you take 3 power x common, you will get 5 by 3 whole power x minus 1 by 1 minus 2 by 3 power x. Now, we have this formula. Limit x tends to 0. A power x minus 1 by x is log A. I am going to apply that formula. Limit x tends to 0. Five by 3 power x minus 1 by x by 1 minus 2 by 3 power x can be written as minus of 2 by 3 power x minus 1 by x. I have divided numerator and denominator with x. Now, this is in the form of a power x minus 1 by x, x tends to 0. So, numerator is log 5 by 3. Denominator minus 2 by 3 power x minus 1 by x is minus log 2 by 3. That is log 5 by 3 by log 3 by 2. So it is in the form of log log 5 by 3 by log 3 by 2. It is in the form of log m by log n. Therefore, you can write log m base n log 5 by 3 base 3 by 2 log m by log n log m base n. Therefore, correct answer is log 5 by 3 base 3 by 2. Next problem. Limit x tends to 0. 2 power 8 cos x by 8x sine power 8 of pi by 6 plus x minus sine power 8 of pi by 6. Now, limit x tends to 0. When x is tending to 0, denominator 8x tends to 0. So, denominator is 0. When x is tending to 0, numerator sine power 8 pi by 6 minus sine power 8 pi by 6, 0. 0 by 0 form. 0 by 0 form comes, we have to apply L'Hospital rule. Yes, Simon Singh, we have to apply L'Hospital rule. Now, differentiation of denominator. Differentiation of 8x, 8. Now, differentiation of numerator. In the numerator, we have two functions, 2 power 8 cos x and sine power 8 of pi by 6 minus x minus sine power 8 of pi by 6. So, you have to apply product rule, UV rule. Differentiation of UV equal to UdV plus VdU. Now, 2 power 8 cos x. Now, differentiation of sine power 8 of pi by 6 minus x. 8 into sine power 7 pi by 6 plus x. Differentiation of sine pi by 6 plus x. Cos pi by 6 plus x. Yeah, first term UdV we have completed. Now, plus VdU. VdU means you have to write this term. Now, sine power 8 of pi by 6 plus x minus sine power 8 of pi by 6. Now, differentiation of 2 power 8 cos x. 2 power 8 cos x log 2 multiplied with differentiation of 8 cos x minus 8 sin x by 8. Yeah, differentiation of 8x, 8. Now, continuation. When x is tending to 0, limit x tends to 0, you got 2 power 8 cos x will become 2 power 8. When x is tending to 0, numerator 2 power 8 cos x will become 2 power 8 cos x will become 2 power 8. 8 is 8. Now, sine power 7 pi by 6 plus x. Sine power 7 pi by 6 plus x. When x is tending to 0, sine power 7 pi by 6. Multiplied with cos pi by 6 plus x. When x tends to 0, cos pi by 6. Yeah, when you come to other term, sine power 8 pi by 6 minus sine power 8 pi by 6 going to become 0. So 0 multiplied with remaining term, you will get 0. So remaining terms in the numerator become 0, but denominator is 8. You have denominator 8, right? Now you can cancel 8 and 8. Now 2 power 8. Sine power 7 pi by 6, 1 by 2 power 7. Cos pi by 6 is nothing but root 3 by 2. Now 2 power 8, 2 power 7 into 2, 2 power 8 cancel. The result is root 3. Now the value of the limit is root 3. Understood? Next problem. Limit x tends to 0. Limit x tends to 0. Limit x tends to 0, tan of pi by 4 plus x power 1 by x. Now you can write limit x tends to 0, tan pi by 4 plus x, tan pi by 4 plus tan x by 1 minus tan pi by 4 tan x power 1 by x. That can be written as limit x tends to 0, tan pi by 4 plus tan x. So 1 plus tan x by 1 minus tan x power 1 by x. Now it is clearly in the form of 1 plus x whole power 1 by x. When x tends to 0, tan x also tends to 0. Therefore, limit x tends to 0, 1 plus tan x whole power 1 by x by limit x tends to 0, 1 minus tan x whole power 1 by x. That gives us numerator is e, denominator is e power minus 1. E by 1 minus e square. Correct answer is e square. Next problem. Limit n tends to infinite n factorial by n power n whole power 1 by n. Try this one. Limit n tends to infinite n factorial by n power n whole power 1 by n. Here limit n tends to infinite, n factorial by n power n whole power 1 by n. Let us take this limit is L. Now take log on both sides. Log L equal to limit n tends to infinite 1 by n log n factorial by n power n. This can be written as log L equal to limit n tends to infinite 1 by n log n factorial can be written as 1 multiplied with 2 multiplied with 3 till n. If you multiply 1, 2, 3 and so on n, you will get n factorial, right? N factorial. N factorial can be written as 1 multiplied with 2 multiplied with 3 till n. Now n power n can be written as n power n can be written as n multiplied with n till n times. Therefore by n. Now if you multiply numerators, you will get n factorial. If you multiply denominators, you will get n power n, right? Log 2 by n plus and so on log n by n. Now this can be written as limit n tends to infinite 1 by n. Here when n is very large, log 1 by n, log 2 by n, log n by n. Here the step length is very less. When n is very large, step length is negligible. That's why I am going to write this series in the form of integral. Whenever n is very large, step length is negligible, you can treat this series as continuous. Therefore log x by n dx. X varies from here 1, 2 till n. Therefore x varies from 1 to n, right? Now let us take x by n equal to t. 1 by n dx equal to dt. When x is 1, t is 1 by n. When x is n, t is 1. Continuation. Log L limit n tends to infinite integral log t. Here 1 by n dx. 1 by n dx is nothing but dt. That's why I am going to write dt here. So log x by n is log t. 1 by n dx is dt. Right? When x is 1, t is 1 by n. When x is n, t is 1. So 1 by n to 1. When n is tending to infinite, 1 by n is tending to 0. That's why you will get 0 to 1 log t dt. Integral log t is t log t, t log t minus t from 0 to 1. By applying the limits, you will get 0 minus 1, 0 minus 0, finally minus 1. Log L is minus 1. That implies L is e power minus 1. So 1 by e. Correct answer is 1 by e. Now, understood? Unacademy also launches explore batches in various engineering fields: mechanical engineering, electrical engineering, and electronics engineering branch. From third semester onwards, you can begin your preparation for ESE and GATE with Unacademy. This is really a great opportunity to college going students. Get Unacademy subscription and learn from top educators using my referral code KUR75 to avail maximum discount. Thank you.